Welcome to Homework Help for Lesson 5.5. We're going to be solving radical equations, and we'll be doing these problems from the homework. So before we jump into our problems, if you don't already have these steps written down from class notes, pause the video and write them down right now, because they're going to guide us through each of our problems. So step 1 says isolate the radical. Isolate means get it by itself. And when we say radical, we're talking about the square root. And the square root looks like this, right? So radical or square root, we're talking about this symbol right here. So we want to get it by itself on its own side of the equal sign. Next step, step 2. We want to eliminate the radical or get rid of it by squaring both sides. This is what it means to square something. You take it to a power of 2. So we're going to get rid of the radical by squaring, okay? Another word for radical is we'll get rid of the square root by squaring. And then what happens is they'll cancel each other out. And that's because the square root and then the square, basically taking it to the power of 2. So these two things, they're inverse operators. So in the same way that addition undoes subtraction, or that multiplication undoes division, taking the square root and then squaring something also are inverse operators. Step 3, finally, we're going to check for extraneous solutions. So extraneous looks like a big word, but look, it just really means extra solutions. So when we get our solutions, we're going to plug them back in and see if they are valid or if they're extraneous. That means that they don't actually work. Okay, let's start. Problem number 1b. So our first step is to isolate the radical. Well, right now, this is the radical. I'm highlighting it. It's the square root and all the stuff inside of it. Currently, it's being multiplied by this 4 out in front, so it's not by itself. So to get it all alone, I'm going to divide both sides by 4. Okay, we're left with the square root of 9 minus w equals 2. So step 1, check. Okay, we isolated the radical. Step 2, we need to eliminate the radical or eliminate the square root by squaring both sides. So watch how I'm going to do this. I'm going to use parentheses purposefully on both sides, and trust me, you'll need them later for more complex examples. So when I put the square on the left side, it cancels my square root. I'm left with 9 minus w equals not 2, but 2 squared. So we've got to square both sides, and I'll get 4 on the right side. Okay, now it's a simple algebra problem. We just need to get w by itself. So I'm going to subtract 9 on both sides. And I'm left with negative w equals negative 5. And in the final step, I'll divide both sides by negative 1. So w equals 5. Now you may be tempted to box your answer right away. But that would be a mistake, because step 3 says we need to check for extraneous solutions. So we actually need to show the work that we're plugging it back into the original equation. So instead of 4 root 9 minus w, I'm writing 4 root 9 minus 5 equals 8. And so I'm just checking right now to see if this is really a valid answer. So let's see. 9 minus 5 is 4. The square root of 4 is 2. And 2 times 4 is 8. So this is true. Now here's where a lot of kids make a mistake. They then say that this is the answer. No. That was just our check to make sure that w really does equal 5. So w equals 5 is our valid solution. It worked. Okay, that was problem number 1b. Let's do a couple more examples of isolating the radical. We're just going to do the first step, okay? So just to get you comfortable with what it means to get the radical by itself. So in example 1, my radical is this piece right here. So to isolate it, what would we have to do to both sides? If you said divide by 3, then you would be correct. And then your next step would be to square both sides at this point. Okay, and example 2. So I'm not going to work these out all the way. I just want to make sure we're comfortable isolating our radical. Okay, if you want to, you can work them out later, and then I'll post the answers at the end of the video. Okay, in example 2, we need to get our radical by itself. So remember, the radical is the square root with everything inside of it. So to get it all by itself, we would have to get rid of this 3 somehow. Since there's a plus sign, we know we're not going to divide by 3. We're going to have to subtract 3 on both sides. And at this point, we would then square both sides. All right, in example 3. This is a two-stepper. So first, to get our radical by itself, we'd have to get rid of this 5. Okay, technically this is a positive 5, so we'd have to minus 5 on both sides. And then in the next step, we still have a negative out in front. That means that there's a negative 1 times. So to get rid of it, we divide both sides by the negative 1. We get root 2x plus 1 equals 1, and now we could square both sides. Okay, in example 4, I need to get my radical by itself. So the only thing that we have to do is subtract x. And so this is the stage at which we would move on to squaring both sides. All right, so if you are interested in testing yourself and seeing if you could actually solve these extra 4 examples, here are the solutions. So give it a shot. Example 4, by the way, is hard. It's from lesson 5.6. Okay, but now that we're okay with isolating our radical, let's look at problem number 2a. So problem 2a is a little different because if you notice, all the examples we've done so far only had one radical, or one square root. Now we've got 2 of them, one on each side. So it doesn't really make sense to isolate a radical since there's not just one to get by itself. But what we can do then is just skip to step 2, and we're going to square both sides right away. So when there are 2 radicals, you just square both sides right away. So we're left with, when this cancels, oh, and this cancels that as well, we're left with 2m minus 6 equals 3m minus 14. And now we just need to solve for m. So we can do this in any number of ways. I'll subtract 3m, and I'll add 6 to both sides. So I'm left with negative m equals negative 8, and m equals 8. But we have to remember step 3, which is we're going to plug that guy back in. Check for extraneous solution. So this could be a solution, but it could be valid or extraneous. That means it works, or it's extra, it doesn't actually work. So we've got to check it. Let's plug it back in. Draw the line so that we know that this is your checking. So we're plugging in the square root of 2 times 8 minus 6 equals the square root of 3 times 8 minus 14. So on the left side, 2 times 8 is 16, and then 16 minus 6 is 10. On the right side, 3 times 8 is 24, then 24 minus 14 is also 10. Since this is true, that means m equals 8 is a valid solution. All right, let's try number 2c now. So number 2c has two radicals, one on each side of the equal sign. So we cannot isolate our radical, but what we can do is square both sides and eliminate our radicals. So let me caution you. Right now, it's super important to put these parentheses. This is where the mistakes are made. Because if you don't put parentheses, let me show you what's going to happen. Okay? If we don't put parentheses, we square, this cancels this, and this cancels this, and you'll be tempted to write, I'm just letting you know, this is the number one mistake. That is wrong. Okay, let me show you the correct way to do this now. Check this out. If we apply our parentheses correctly, remember it has to be around everything. Here's what happens. This cancels. I'm left with 3k minus 1 on the left side. But then this is really 2 root 5 minus k times 2 root 5 minus k. So not only is the 5 minus k going to escape from its radical sign because it's being multiplied by itself, but also the 2 has to get squared. So really there's a 4 out in front. So in a way, you can think about it as if this exponent is being distributed. And we get 2 squared, and also it cancels out. So you've got to be wary. Use your parentheses and make sure that you're applying the exponent to every factor. Okay, so since the left side was the incorrect way, let's continue over here on the right. We get 3k minus 1 equals, so we have to distribute now this 4. 20 minus 4k. And now we'll just group our terms. So I'm going to move my k's to the left side. I get 7k. And then I'm going to also add 1 to both sides. Okay. Dividing both sides by 7. I get k equal to 3. We're not quite done. We've got to check our solution. So let's plug it back in. Okay, original equation said square root 3 times 3 minus 1 equals 2 times the square root of 5 minus 3. Alright, 3 times 3 is 9 on the left side, and 9 minus 1 is 8. And then 5 minus 3 is 2. So now we have to ask ourselves, is the square root of 8 equal to 2 square root 2? Well, we can actually simplify this. Even though at first it looks like they're not equal, if we break down the square root of 8 like this, or using our waterfall method, we see we can pull out a group of 2, and we're left with 1, 2 inside, so the square root of 8 really is equal to 2 root 2. That makes k equal to 3 a valid solution. That one was a little tricky with the plugging in. Alright, last problem. So number 3b. We have a radical is on the right side and it's already isolated. So we're going to jump into step 2, which is square both sides, not just the one with the radical, both sides. So on the left I get r squared, and on the right r plus 56. So what makes this problem different from all the previous problems we've done so far is now we have a variable being squared. That means we're dealing with a quadratic equation. And to solve quadratic equations, we have to set everything equal to 0 first. So we want to bring everything to the same side, and then we have to factor. That's how we'll solve our quadratic equations. So we have two options. We can either bring these guys to the left, like this, if I minus r and minus 56, Or I can bring this guy over to the right and be negative r squared plus r plus 56 equals 0. So my general tip to you is when you have the option of moving things around, right? You're trying to set it equal to 0. Your best bet is to keep the variable that's being squared. You want to keep its coefficient positive. So this guy is going to be much easier to factor than the one with the negative in front. So try to avoid having a negative x squared or a negative r squared. We're going to move everything to the left side in this case. Okay, I'm going to factor this using magic x. So I need two numbers that are going to multiply to negative 56 and add up to negative 1. So be careful with your signs. They're going to be 8 and 7. The one that's negative is going to be 8. Negative 8 plus 7 gives me the negative 1. And then we'll factor. Okay, so if I have r minus 8 equal to 0, I get r equals 8. And if I have r plus 7 equal to 0, I get r equals negative 7. So we got two solutions. But before we go ahead and box, let's check. We have to check both of them. See if one of them is valid or extraneous. It could be both valid or both extraneous, so you can't just guess. Okay, let's plug it in. I'm doing 8 first. 8 squared equals the square root. Oh, whoops, I made a mistake. The original equation is just r, so I'm just going to plug in 8. Equals the square root of 8 plus 56. Okay? So 8 plus 56 is 64. And the square root of 64 is 8. 8 equals 8. So this is valid. Okay, this was a valid answer. Now let's try r equals negative 7. So I have negative 7 equals the square root of negative 7 plus 56. Alright, so negative 7 plus 56 is 49. The square root of 49 is 7. And negative 7 is not equal to negative 7 is not equal to positive 7. So that makes this an extraneous solution. So in your homework, you're going to write r equals 8, valid, and then r equals negative 7, extraneous. And we're done. So I promised you some answers to those challenge questions, and here they are. Take a screenshot and see if you can do all of examples 1 through 4. Hopefully that was helpful. I'll see you next time.